Welcome to part 3 of Unit 2. We're going to talk about proving segment relationships and the difference between properties of congruence as opposed to properties of equality. So last video, we were talking about all the properties of equality. And some of them are true when it's congruent, but some of them aren't. So the first postulate that we want to talk about is what's called the segment addition postulate. That's basically when you have three collinear points and a point between those two. So notice that part of the whole segment plus the other part is equal to the whole thing. So whenever you think segment addition postulate, it's part plus part equals the whole thing. Then some of the property segments of congruence. So you have the reflexive property of equality, you also have the reflexive property of congruence. The symmetric property of congruence, where you notice if a segment's congruent to another segment, then you can switch them. And the same thing with transitive property of congruence. Notice they're both congruent to the same thing, CD, so then they're congruent to each other. Now, there is no substitution property of congruence. So whenever you have congruent segments, it has to be the transitive property. So for example, PQ is congruent to ST, and ST is congruent to UV. So notice they're both congruent to ST. So then PQ is congruent to UV. This is the transitive property of congruence. The segment is congruent to itself. That is the reflexive property of congruence. If H is between G and I, then GH plus HI is equal to GI. That is the segment addition postulate. Part plus part equals whole thing. So then notice the next thing, it says to state a conclusion that can be drawn from the given statement and property. So if W is between X and Z, and we're talking about the segment addition postulate, if you draw it out, here's here's X, Z. W is between them, so that means XW plus WZ is equal to XZ. Transitive property, if LM is congruent to NO and NO is congruent to PQ, so they're both congruent to NO, so that means LM, segment LM, is congruent to segment PQ by the transitive property of congruence. All right, so then let's look at a proof here, So, trying to get it in the picture. There you go. So it's given that GD is congruent to BC, BC is congruent to FH, and FH is congruent to AE. So when we list those in the first step, that is given. Now we're trying to prove that AE is congruent to GD. So what we need to do first, since we know that GD is congruent to BC, we're trying to say that BC is congruent to AE. So what we need to do is set up some way to relate that GD is congruent to BC. Well, notice GD is congruent to FH because they're both congruent to BC, and that would be the transitive property of congruence, because they're both congruent to the same segment. All right, so then we know that GD would be congruent to AE since GD is congruent to FH and FH is congruent to BC and AE. So basically, GD is congruent to AE by the transitive property as well, since AE is congruent to FH and GD is also congruent to FH. And then since we just need it to be written as AE is congruent to GD, that would be the symmetric property of congruence. All right, so that's our video on proving segment relationships, and then next we'll get into angle relationships.